I guess I should plug right now that if you are interested in building on Substrate and you kind of have no idea where to start, tomorrow at 10 a.m. we have a workshop set up. So you can definitely show up there, look at the calendar. I think it has the most recent room location. All right. Okay, so I was saying, my name is Shawn Tabrizi. I'm a developer at Parity Technologies. And today I'll be talking to you how Substrate enables forkless runtime upgrades, or forkless blockchain upgrades. A little bit background on myself. I spent 4 years working at Microsoft, working on cloud identity and cloud infrastructure. Then during my time at Microsoft, I got interested in Ethereum dApp development. And now I'm focusing on Substrate and Substrate development. Mostly working on building runtimes and something that you heard about and something I'll talk about more in my talk. So to give you an overview, first thing we're going to talk about is blockchain upgrades today. We've talked about Substrate, Rust and Wasum as building blocks for Substrate, forkless upgrades, and of course how you can build on Substrate at the end of this talk. So I guess to jump in blockchain upgrades, really what we're talking about here is software upgrades, and really software upgrades to nodes. So as you upgrade all the nodes to a network, then the actual network will change and act accordingly to the upgrades that you did on the nodes. And there's really kind of two ways you can do an upgrade. We have this idea of a soft fork, which is kind of a nicer way to upgrade. It kind of limits what you can do, but in general, the nice thing about soft forks is that old nodes will still maintain compatibility with the network. So you can have a bunch of new nodes and new software out there. The old nodes will still accept and agree to the blocks that are being produced by that network. But what you still have to do to upgrade the network is to have the majority of nodes actually upgrade that software. So even though old nodes kind of stay on the old software and continue to work, majority of nodes have to upgrade such that more blocks can be produced with the new logic than the old logic. But soft upgrades are something that we use all the time, and it's actually a really kind of good upgrade mechanism. The kind of thing that we really talk about right now is hard forks, and this is kind of a more, I guess a way you can do it's more disruptive to the network, but allows you to do like larger upgrades. Basically, hard forks are changes to the protocol or to the code, which is incompatible with older software. So as you create this new software, the old nodes which don't upgrade will not be able to talk to or gain consensus with the new node software. Really, in order to maintain consensus in the network, all nodes and all miners have to upgrade to the software in order to maintain part of the network, or they will fork off. This is the hard fork part of it. And there's kind of two ways this has happened in the past. You have these like contentious or disagreement upgrades, things like Bitcoin to Bitcoin Cash, Ethereum Classic, where there might be some disagreement on how we should move forward, and two kind of networks spin out. But also you have things like, that are planned, that are upgrades. Things like, the Constantinople upgrade that just happened with Ethereum is a planned upgrade. And, usually it's not contentious and everyone kind of goes in upgrades. But still, you have the possibility of forking your network. And I'm going to talk a little bit about that. So let's look at a hard fork upgrade. So you can see we have a block up top. We're running some old logic. And we decide some time, some block number. We're going to have all these nodes, upgrade their software. And at this block number, change to a different, consensus algorithm or change to a different protocol, which is something that's not compatible with the old one. Unfortunately, actually getting all of the nodes to upgrade their software is a big task, and not everyone will upgrade at the same time. So what you end up happening for a period of time, maybe even forever, is that having old nodes producing blocks that are incompatible with the new network, and you actually have this fork, where you have a blockchain of new logic and a blockchain of old logic. And this is kind of not a great thing for, blockchain upgrades. It makes it kind of the whole process really kind of nasty. And what we've seen in the past is there is a need for upgrades. Blockchains are meant to be kind of these persistent for long periods of time. And there's no perfect blockchain today. That's why we're all here kind of developing blockchain technologies. And if there was, it probably wouldn't be for long. As time and technology develops, you want to also be able to iterate your blockchain and make it usable for the modern day. So things you might want to upgrade still in the future, like things like important security vulnerabilities, changes to rules or the protocol. You can add new functionality, or you can even repair the chain state. And in general, I was mentioning blockchain upgrades or hard fork upgrades require a lot of coordination. You need to have all these people who are running nodes, who are running the infrastructure, to know when the upgrade is going to happen, to download the new software, run it, maybe even take down their node at the time that they actually do the upgrade. And this is such a kind of a hard problem that even the Ethereum Foundation right now is asking for a person as a hard fork coordinator for such a job. So this is really a big task. And it becomes even a bigger problem when you start talking about governance and signaling towards how do we make an agreement on what the right upgrades are and what the new software should be and if we should run it or not, right? This whole kind of process is not really handled, I guess, in a fixed way. So it's kind of hard to understand exactly what should happen with upgrades. So when building Substrate, we decided to make upgrades a first-class citizen of the entire process. So before I jump into that, I want to tell you a little about Substrate. So I'm sure all of you have been kind of hearing about it all day, but to give you a quick overview, Substrate is an open source, modular, and extensible framework for building blockchains. Really, you get all of the core components needed to build a blockchain. Things like the database layer, the networking layer, consensus engine, transaction queue, library of runtime modules, and the best thing about this is that all of these different components are customizable and extendable, so that you can go and kind of take this framework and take your idea for what you want to do, take the pieces that you don't need to rebuild, know that you have some production ready level software, but then also modify the things that you do want to modify and get your own custom logic, whether it be maybe a new networking layer, maybe be a new runtime module, or anything like that. So let's talk about the library of runtime modules. So what is a runtime? The runtime really is the block execution logic of the blockchain, right? Or we call this the state transition function. It's like all of the actual things that the blockchain does from block to block is handled in this runtime. And in Substrate, it's composed of these things called runtime modules. So you have these different modules which all have their own kind of special functionality, and you can pick and choose from them, like we've done here, and create an entire runtime which actually defines what your blockchain does. We have this, again, I mentioned a runtime module library which comes with Substrate, and again, all of these things you can choose and pick from and actually build your own custom runtime. And of course, you can create your own too. So let's look at the runtime and how it fits into the overall Substrate architecture. So you can see it's actually, the runtime is wrapped within a WebAssembly consensus and networking layer. These are all written in Rust and built into a native binary. But then you also have the runtime itself, which lives inside of the WebAssembly, which is also written in Rust, but it's built into both the native and Wasum binary. And this is really powerful. And we're going to talk about these technologies and kind of how they work to enable this forkless runtime upgrade. So one of the things you might notice is that the entire stack of Substrate is written in Rust. And it's a new system programming language, which is started by Mozilla and known for powering Firefox. And it's actually a tool that we have parity used for nearly all of our clients. So it's just something I want to talk to you about. So why do we choose Rust? Well, as I mentioned, Parity is a Rust team as much as it's a blockchain team, but you get a lot of really amazing things when you use Rust to build systems. You get inherent safety. So Rust ensures that programs are free from undefined behavior, any data races, any memory safety issues, and that gets all free when you compile your code. If it compiles successfully, you get these things for free with Rust. Rust is crazy fast, and most importantly, it's very lightweight. So it has almost zero runtime overhead, and it produces really, really fast, lightweight code. Then, as I mentioned, also we have a WebAssembly. So we use WebAssembly for the runtime as kind of a general platform-independent execution format. Wasum is great for this runtime environment because it's sandboxable. To protect user from buggy or malicious code. It's deterministic when you remove floating point arithmetic, which is obviously very important for blockchain systems. Wasum is built to be very close to the native. Is really close to your native execution engine, so it runs really quickly and can go near native speed. And then also Wasum is very compact, so it can be easily transferred to the web, and it was built as a web format. And so as I mentioned, both Rust and Wasum also work very well together. You can see that Rust builds directly to Wasum, which allows for the same code base to generate both the Wasum binary and the native binaries that you would run on your computers. So without having to maintain two different forks of the code or having to maintain two different pieces of technology, you can have a single code base generate both kinds of binaries. And we have built a Wasum Interpreter in Rust that allows you to run Wasum binary, and it's something that we've integrated into Substrate. And as I mentioned, because Rust is very compact itself, and Wasum is very compact, you actually end up with really small Wasum files, which is kind of how the runtime actually lives when you finally build it. So if we think about, okay, we have this really small Wasum file, what we can do actually now, which we couldn't do before, is actually store the Wasum file on chain. And this is really the magic that allows us to do these forkless runtime upgrades, that this small Wasum file, we can actually put it on the blockchain and have people get consensus and agree over what is the correct runtime of the blockchain at a certain point in time. And so we take a look at the logic that actually enables what a forkless runtime upgrade does. You see here, we have the Wasum on chain, and we also have the native client running. If the version of the runtime on the chain is different than the native client that you're running, we actually fall back and use the Wasum runtime in a Wasum interpreter that we built, and actually execute blocks using that version of the code that's on the chain and that has consensus. If the version of your runtime is the same as it is on chain, then you actually just run the native binary on your computer, and it's much faster, but it ensures at all points in time that anyone running your chain will always be in consensus, because you can always know that everyone's running at least the same runtime logic with the same version. And it's really this kind of fork in the code that enables us to maintain consensus through upgrades without having to cause any forks. So one of the things to talk about, when you're talking about runtime upgrades is, it's obviously a very powerful process and needs to be treated with such. So when we talk about, how can you just upgrade your chain, we also need to think about like, okay, what are the governing rules around upgrading your chain? So the runtime code is stored in our substrate database, which is basically a key value store, and it's stored under a special key called code, and it's accessible through our consensus modules, one of the modules that you get when you build on substrate. And you can actually call this set code function in different ways. One of the modules we provide is something a pseudo or add-in module, which is great for if you're doing like testing or doing any type of like private networks where you want to have a single key be able to control the runtime, and that key can basically call into the pseudo module and directly change and upgrade the code of your blockchain. For more like public or distributed systems, we have an entire like on-chain governance system built across a number of modules, which allow you to propose and have people vote via democracy and via councils what upgrades should happen, and make sure that if an upgrade happens to the network, it's something that was decided by the network, and it's built in a distributed kind of decentralized system. And then finally, of course, if you're building on Substrate, you can control runtime upgrades with your own module, your own logic. So you don't have to use our on-chain governance system. If you have an idea for how you want to do it, or you have some other alternative way you want to touch the runtime logic and upgrades, you can, of course, build your own module and logic for that. And I guess the most important thing to talk about is runtime upgrades are optional. So you could also build a blockchain on Substrate which doesn't have runtime upgrades at all. So if you want to make sure your blockchain makes sure it has a fixed state and never changes, that you can go and just remove the runtime upgrade option, and you just never have to worry about this pathway. So one thing I want to talk about is creating dApp chains on Substrate. So Substrate is, of course, built to be a really powerful platform for building any kind of blockchain, things like UTXO chains like Bitcoin, smart contract chains. But I think one of the things that are most accessible right now, and especially to you all here at an Ethereum conference, is maybe development of dApps and development of dApp chains. So I want to talk about some of the, the problems with modern dApps and their facing scaling issues. So right now, if you're building a dApp, you're going to run into problems where you're going to have to compete with other dApps on the same network that are trying to compete for basically transaction priority, resources. You're going to have to take the security of whatever network you're on. So even if your dApp is not maybe the most important multi-billion-dollar service, it's supposed to be something fun like a game, you still have to maintain the security of whatever network you're on, and that can be kind of expensive and not really performant for your dApp. And then, of course, upgradable contracts are a thing, but usually it involves having that contract be controlled by a central authority. So it's really, there's kind of some problems here with dApps on the current platform. But I'm proposing that dApp chains on Substrate can actually solve some of these problems. So as you mentioned, things like transaction resources, transaction fees. When you control your own blockchain, you control what the fees you impose on your users who are using your blockchain. You can control how the resources are managed and how they're, basically how your blockchain runs entirely. You can choose the right security model for your blockchain. If there's a different consensus protocol or a different system that you think is beneficial, that has the right weighs the right options between security and scalability and speed, you can, of course, choose that because you control the entire blockchain stack. And, of course, as I mentioned before, runtime upgrades, you can control how the upgradability happens, whether it be something you want centralized or something you want distributed in a more on-chain governance system. And that really makes it really powerful. So, one of the things I wanted to ask, or wanted to show you here is what would happen if we had the CryptoKitties like dApp, but it was built on Substrate? And that's something I wanted to demo to you right now by doing an upgrade. So you'll have to give me a second. I'm doing a little bit of a hack here because I wasn't able to project from my screen. I'm going to be sharing my screen over a chat service and see if this works. So give me 1 second. Okay, so let's try this. then, give me 1 second. Go over here. Let's connect on Zoom. 243 994 125. Let's see if this works. Let's cross your fingers here. This is true bootstrapping. Okay, let me share my screen over here. And then we might get a little bit of lag, but it looks like it's working. Yep. Okay, so I'll show you everything. Oh, I need to close this window. It's blocking the view. I hope this is continue. Okay, good. I did not break anything. Okay, so let me show you what I got here. So I have a project open. This is a Substrate project. There's 2 folders here. There's something called Substrate Kitties and Substrate Kitties UI. Basically, Substrate Kitties is kind of what we call the Substrate node template. It's basically something you could download out of the box, and you can basically start hacking Substrate right away. In this node template, I've only really changed 1 file, which is my new module, which is kind of controlling this new Substrate Kitties, I guess, functionality of my blockchain. And then the second folder here is the Substrate Kitties UI, which is a React app, which you can also just download out of the box, and it will work out of the box with the node template. And then you can, of course, modify it to add new UI elements or new functionalities that your blockchain represents. So if we go into the Substrate Kitties project, part of Substrate, you can see here I've introduced this 1 file. And actually it breaks down pretty simply. So I've minimized a bunch of the code, but if you could look at the overview here, we have a structure, which is like the kitty struct. You know, it has things you might expect like DNA, prices, generation. We have an event type. We have a macro for declaring all the events in our module. So things like, you know, a kitty being created, a price being set, things being transferred. This is like, again, it's supposed to be like a minimal version of what CryptoKitties might look like on Substrate. We have a declare storage macro, which declares all the different storage items that our module manages. And of course, we have a declare module macro, which goes and actually creates all the public functions that you can use to interact with this module. Things like, you know, create a kitty, set a price, transfer, buy a kitty. These are all the things that are there. And so what I'm going to do real quick is I'm going to run this. 1 second. So I will go target release substrate keys. Allow. Then I will also make sure that there is my Node.js project is running. So if I refresh this page, you can see I have a blockchain running. So you can see here that it's a height 1, and if I go to the Explorer and I make this a little bit smaller, let's see, we should see, new blocks being produced. No. Yeah, it's loading. Okay, so we see new blocks being produced. So I have a local blockchain running here. What we can do, you know, some basic blockchain stuff here that we can like send funds. So I'm gonna send funds from Alice account, and Alice is pre-funded with a bunch of money, and send it to myself. So let's do that real quick. So I'm gonna send myself 10,000 units, and it works. Okay, so we have here, and we see some events. That's great. And then we also see here we have actually my module here. So I've already written some UI that allows me to create a new kitty. So I can write my name, create a kitty, and when the block gets produced, we should see a new cat appear. So what I'm going to show you now is basically we're going to add new functionality to my runtime, do a runtime upgrade, and show that my UI can reflect those new changes. So let's actually create 2 cats, because what we're going to do is the new functionality we're going to build is breeding. Give me 1 second real quick. So over here in our runtime, I have written some code, and we can actually walk through real quick. It's a new function called breed kitty. Basically what we're going to do is we're going to take 2 cats, use their DNA, mix them together, and produce a new cat using those DNA. And hopefully this cat will have elements from both of the kitties that were used to generate it. So if we copy this code, and we add it to our declare module macro, and I save this, what we need to do now is rebuild the Wasum. So again, as mentioned, the runtime is stored as a Wasm file, and what we can do is run this script, which will actually generate a new Wasm file based off of the new function that we've, or the entire new runtime that we built here, which includes this new function. You can see here, okay, it's created. Now I want to go back to my UI here and select the runtime to be upgraded. So you can see here, this file was created today at 5:32. It is 5:32. We'll click this. We will press upgrade. And the last thing I want to show off here is that my UI has basically an if statement where if the breed functionality doesn't exist, it will hide some UI elements. But if it does exist, it'll show you some new UI. So before you saw we could only create a kitty. But if the breed functionality exists, you'll see some new buttons and new UI which allows you to breed a kitty. And this is kind of one of the powerful things. We can see an upgrade happen live. So at the very end here, you can see that there's a event that was released called suited, which is, again, from the sudo module, saying that we have upgraded our chain. And if I refresh this page and scroll down to our kitty app, you actually see there's new UI elements here, which represent, hey, we have a breed functionality, and let's actually try to use it. So if we have these two cats, this one has a monocle, is gray with a spot, this one has a scarf. If we take their DNA, and we try to mix them together. Sorry, I'm doing this one-handed right now. And we have to give it to someone, so let's give it to Alice. Okay, and let's breed a kitty. And hopefully, if the RNG gods are good on me today, we'll get a new cat here. Like I said, this one has the scarf. It has the flask that this one has. It has this smile, has the same color. And you can see here we've basically taken a chain, adapt chain here, added a new functionality to it, upgraded it without any problems, any forks, or if you have to restart your node. And we were able to basically introduce and upgrade our chain in a forkless manner. Nice. Okay, so let me exit here. I just have one or two more slides at the end. Let's go back to here. We did an upgrade, and it worked. Good. Is this loading? Okay, yes. So I want to talk about this workshop. So everything I did, and I showed you right here about building a CryptoKitties chain on Substrate is something that we have available as a workshop. So we can teach you how to run a local Substrate node, about runtime development, teach you all the best practices, building a working chain with UI, and even if you have minimal Rust experience, we're taking that into account and making sure that you're able to get through the entire process and kind of learn how to build your first chain. And so this is something that we offer, and I think anyone today here can use this URL and pick up and build the chain that I showed you today, including a runtime upgrade. And as I mentioned, tomorrow we have a workshop at 10 a.m. where we will, myself and another developer at Parity will be working through this, this workshop and basically talking you through the process, showing you how it's done, answering any questions, and making sure that you are able to leave today or even work on this hackathon this weekend, building on Substrate. So this is a really great first step for anyone who's interested in building on Substrate. We make it as easy as possible with hopefully an idea that you're all familiar with and translating those ideas to Substrate and Substrate world. Yeah. So let's go overview. I talked about Substrate, I talked about Rust and Wasum and how they enable these very small Wasum files which can be stored on-chain, which allows you to do these forkless upgrades. And finally, I talked about the workshop, which you can all access today and learn how to build your first Substrate chain. We're hiring. If you're interested in Rust, interested in blockchain development, you can go to parity.io/jobs. We have an events and updates subscription that you can go to on the newsletter. And finally, you can ask me any questions if I still have time. Thanks.
Questions for Shawn? We're running low on time, so one or two.
Yeah. Hey.
Great talk.
Thanks.
So if you're running your own blockchain, it's the sort of liveness of it depends on there being at least sort of one node online at any time. What happens if it's a very small group of nodes and they're all offline? Does the blockchain sort of pause and continue, or is it relying on liveness from another source?
Yeah, I think these the Substrate nodes aren't much different than any other blockchain nodes. So if all the Bitcoin or Ethereum nodes went offline, blocks would stop getting produced, and the network would halt. So in this demo, I only have one node I'm running locally. If I stopped it, yeah, blocks would stop being produced, and if I started again, I would pick up right where I left off. I'd be able to continue building new blocks off of the last block head. The Substrate is built such that you can produce these node binaries, release them, and they'll automatically find each other using the networking layer. We use libp2p, and as long as there are nodes out there, basically this network will be producing blocks that other people using your same blockchain can find. And yeah, I mean.
Yeah, that's cool. Okay, yeah. Great, thank you.
Any other questions? All right. Okay, thank you.